Takes a little bit of time. Oh, that's very loud. So, hello. We're going to be working on the abacus. We are going to be looking at this abacus. So, this is a counting tool. So, we're going to count 1, 2, 3, 4, and then we have 5. After 5, we have 6, 7, 8, 9, and then 10. So, if we look, we're reading the abacus. And how are we going to do the abacus? 1, go live. Okay, so what we're going to do is we're going to read the abacus. So we're reading 1, 2, 3, 4. Any of the beads that are lower to the bottom, right, is going to be a value of 1. This is the horizontal bar, and every time the beads touch the horizontal bar, this is being counted. Because this is being counted, this is 4. Does that make sense? Let me know in the comments if this makes sense. Put a 1. Put a 1 or a HB. Let's put HB in the comment, because then I know you're a horizontal bar. So because the beads are touching the horizontal bar, this is what we consider counted. So all of these are counted. This is 4. 1, 2, 3, 4. And they're all, holding hands and stuff. Hello. So what we're going to do is we're going to understand that this is 4. And that's what we have. We have 1, 2, 3, 4. So we have 4. 1, 2, 3, 4. All of these beads that are touching this horizontal bar is now being counted. Because it's being counted, it is being number 4. This is number 4. This is number 3. This is number 2. This is number 1. This is number 1. Welcome, everybody. Happy Friday. Happy Friday. And so the question is, well, what's after 1? After 5? Well, after 5 is I'm sorry, after 4 is 1. After 4 is 5. The top beat will always be 5. So that's what this is. We are counting on the abacus. An abacus is the forgotten math tool. So this is 5. This is the top beat. The top beat will always be 5, no matter what. So remember when we counted, this is 1. But then when we add the 5, it's now 6. Now notice if I have 2 and I add the 5, right, now we have 7. What happens after that? Well, if I have 3, we know what 3 looks like because that's what happened in the beginning of the live. In the beginning of the live, I had 3. Now, if I add the 5, now we have 8. Make sense? And then what's going to happen is if I have 3 and I have 4 now, this is 4. How do I know? 1, 2, 3, 4. Now, when I add the 5, we have 9. Make sense? So let me know in the comments where everybody's coming from because it's pretty late. Hello, Lando. Welcome back. I'm so happy you're here. How are we doing? You all right? Today's Friday. I wonder if it's Friday for you. Let me know where everybody's coming from. But what we're doing is we're reading the abacus. After we learn how to read the abacus, we're going to do some adding, subtraction, multiplication, and maybe we'll hit some division. And I was working on a little couple of knickknacks. Knickknacks. Okay. Lando, if you have any questions, because you're the only ones commenting, let me know if you have any questions. So I have 1, 2, 3, 4. We're great. Puerto Rico. Whoa. That's so late. Isn't it like 1 in the morning? 4, 3? It's really late for you. What are you doing up? We have 1, 2, 3, 4. Because, yeah, see? I don't know. I'm so happy you're here, but woof, midnight mathing, I'm telling you. Hello, Kate. Welcome back. Welcome back. So we have 4. 1, 2, 3, 4. We can actually, depending on how the class goes, we can probably go into multiplication and maybe we do some division. What about that? What do you think of them apples? Right? Okay, but it also depends on my energy too, because to me it's 10:30, and so let's see how we're doing. But Lando's in Puerto Rico, but holy cow, man, that's late. I don't know if I'd be doing midnight mathing at 1 in the morning. You guys are nuts. I'm happy you guys are volunteering, learning how to learn math in the middle of the night. So we have the 5. This is 5. Thank you for the follow, Rossi. We have 5. This is 5. This will always be 5. So, see, midnight math by me too, right? So you guys enjoy midnight math. That's what we're calling it, midnight math. Okay, so we have 5, and then we notice we have 1. So if we have 1 and I add the 5, now we have 6. And if we have 2 and then we have 5, now we have 7. If I have 3, 1, 2, 3, and I add the 5, now we have 8. Are we okay? So then after 8, we have 4. 1, 2, 3, 4. We add the 5 and now we have 9. Lando, did you learn how to read the abacus? I mean, if it's just us, let me know what you guys want to go. I mean, we could go straight into adding and subtracting, or we can go straight into multiplication if that's what you guys are already understanding. But those are like the people that are caught. Yes, earlier. Okay, so you know how to read the abacus. And then did you do the maze? Did we do the maze? We did the maze. So then here was another thing that I was like working on. So if we were looking, and if those people that are signing in, yeah, the maze, right? So people that are signing in, what we're going to do is we're going to read the abacus. This is 0. So on my picture, this is 0. So when we have 0, thank you so much for the likes. Woo! I'm already at 800 likes. So this is 1. How do I know this is 1? Because we have one bead and it looks like that. And what I'm going to do is I'm going to color it in. I'm going to do 1. So that was 1. And then we have 2. How do I know? We have 1, 2. So we have 2 on the abacus, and we have, thank you so much for the likes. So we have 2 on the abacus. We have 1, 2 on the abacus. We have 2 in the picture. Now we have 3. When we do 3, 1, 2, 3, we're going to have 3 on the abacus. Easy, right? Easy? It's easy. Not as problem. Simple to use, easy to understand. So now we have 4. Thank you so much for the likes, everybody. And now we have 4. So on my picture, I have 4, and then on my abacus, I have 4. And what are we going to do? After that, we have 5. Notice that the top bead will always be 5. Thank you guys so much for the likes. Wow, there's already 20 people in this room. So what we're doing is we're learning how to read the abacus. And so when I have 5, this is 5. The top bead will always be 5. This is the top bead. I'm not going to color it all in because then it'd just be a big blob. So we have 5, and then after 5, we have 6. What do you mean 6? Well, if you notice, we've done the 1 before, right? We've done the 1 before. Then what we do is we add the 5. Now we have 6. 5, 6. And now what we can do is we can start counting on. And so in the abacus, we learn how to count on. That is a kindergarten skill. So what we're going to do is we're going to have 2. We notice we have 2. 1, 2. And then what's going to happen is when I add the 5, 5, 6, 7. I add the 5, 6, 7. So now I have 7 on the abacus. Oh my gosh, thank you guys so much for liking the live. So then we have 7, and then after 7, we have 8. Notice 8 looks like 3. So when we have 3, 1, 2, 3, and we add the 8, then, we add the 5, and now we have 8. Thank you for the follow, everybody. So we have 5, 6, 7, 8. Does that make sense? Anybody have any questions? Let me know. Thank you, Mac, for the follow. Just stolen. What did you steal? Just stolen. Don't steal. So look, if we have 5, you've stolen the knowledge of abacus and go through and understand and educate the rest of the world. Okay, so we have 4. We have 4. 1, 2, 3, 4. And then what are we going to do? When we add the 5, why is there 7 columns? 7 columns, and this is 9. 7 columns is our digits. 5, 6, 7, 8, 9. Just like how we write. Why is there 7 columns? Because that's how it's built. That's all. That's really it. But when I look at it, I have my ones, my tens, my hundreds, my thousands, my 10,000s. Thank you, Max, so much for the comment. Okay, so the blue bead is a value of 5. Exactly, Angelita. When we look at it, we're going to do 1, and then when we add the 5, we're going to now have 6. So now, Mac, when we look, if I want to add 5, this is not 5, this is 50. Because it's just like how we write This is 50, a 5 and a 0. So if we have 50 and then 60, and then now we can count by tens, 60, 70, 80, 90. Does that make sense, Angelita? So then, thank you for the follow, Miss OP1, OP1 Kenobi. So when we look at it, we're going to do hundreds. When we do hundreds, we have 700. We have 700, 5, 6, 7, 50, 0. And that's what I have. This is what I have. So just as we write is the way we have our abacus. Does that make sense? Let me know if you have any questions. But, I was wondering why see, that's because you have attention to detail. So why am I starting in the middle? The reason why I start kind of in the middle is because I have this thing called the dot indicator. This is my ones indicator. This ones indicator tells me where the ones place is. So you know how like you have Pokemon, right? You know how you have Pokemon, you choose you. I choose this dot. So that means I'm going to choose this dot to be my ones place, as opposed to I could choose this one to be my ones place. So then I would have to shift everything over, and now it'd be labeled ones and tens, and then I cannot have any hundreds. But I'll have a lot of beads for my decimal. Oh, thank you for the share. So what I was sorry. It's because of the dot indicator. Yeah, the dot indicator is like my little Pokemon. So, what would this be used for? Family tree version. I always wanted to read the abacus. This is so fun. What would this be used for? This would be used for adding, subtracting, multiplication, division. Usually it's for young kids because we want them to have number fluency, number flexibility, number sensibility, number sense, and all the other number terminologies that we have. What is it for adults? Why do we want to do it for adults? We want to go for adults. The reason why it'd be nice to learn how to do the abacus as adults is because we want to do brain gymnastics, just like why we do Sudoku, crossword puzzles, and word searches. Does that make sense? Can you show how to use it on multiplication? Yes, we can do it multiplication, but I would like to go through. Thank you. I am Securi. Thank you so much for the rose. So, family tree. Did that make sense? Why are there hand movements? There's hand movements because I'm very excited. But you know when those kids are doing this and they're doing all the gang signs, it's because they're doing the abacus. It's a little bit dramatic, but yeah. Yeah, not a problem, family tree. That's a very valid question. Because a lot of people are like, what's the point of doing this? So some people will find it is a little complicated. And it can be a little complicated, but if you're not open to it, everything will be complicated, right? So what we're going to try to do is we're going to try to embrace a new way of thinking, which is not actually really new way because abacus has been around for such a long time. This is actually the old way. This is the old way and it just happens to be new way. So, but now it's actually the forgotten way. This is so, it looks easy. It is easy. It is easy. It is very easy. So the first thing we're going to do, thank you everybody for the comments. Thank you so much. It is very easy because when we look at it, we just need to do is the first thing we need to do is understand how to read the abacus. So to understand it, we know this is 1, 2, 3, 4, and then we have 5. After 5, we have 6, 7, 8, 9, and then 9, we have 10. Notice we have 10 just like as our columns. So if our ones are tens, our hundreds, our thousands, our 10,000, right? So what's going to happen is if you notice that this is my ones indicator, this is my ones label, it's just a label. Then you know after the ones will be the decimal. So we have our decimal that sits between the ones and the tenths. Why? Well, this decimal, right, this decimal doesn't sit on an actual place value. It sits between. So just like we do on the abacus is what we do when we write, when we do the tenths and the hundreds. So that was the other reason why we may have like these two columns at the end is because we can use money. Because abacus was used for money, like adding and subtracting the money, right? And doing exchanges and stuff. Yeah. Thank you so much for the hearts. Thank you so much for so. Anybody else have any other questions other than multiplication? I mean, we could do it, but I don't want to confuse anybody. Let me see. I would have to think of another. I would have to think of a multiplication question that everybody would understand. Which I need to do. So let's see if I can do it. You know what? Let's jump ahead. Let's jump ahead and see if we can do some multiplication. But we do need to understand addition. So, Angelita, I'm just saying, if I show you multiplication and if you get annoyed and you don't understand, don't say that I'm a horrible LA dictator. Right? That's what I'm saying. I think it was better if we start with addiction. Yeah. Addition? Okay, we'll start with addition. Okay, we'll start with addition. I was on your live. Right, Kit Kat? Yes, I saw you. More adding. Okay. No, I don't know, Angelita, because then there's people that are coming into the live and they're like, I'm so confused. I don't understand why it's so difficult. And it's not actually difficult. I mean, you just need to understand how to read it. Okay, we'll do one and then we'll go back to addition. How about that? Is that all right? Is that all right? We'll do one multiplication and then we'll go back. No, do it. Okay. We'll just do one and then we'll go back to multiplication, addition. The reason why is because we need to lay the framework. We need to lay the foundation. When we lie down the foundation, then we'll be able to understand why I do the things we do. That works. Thank you. Thank you. Thank you. I appreciate that. Okay. Thank you guys, everybody, for I just gotta find a nice one. I just gotta find a nice one. Okay, we'll do a nice one. Here is a nice one. Okay, we'll do the easy one. This one's easy. Is it easy? How is easy? How is multiplication easy? Okay, we'll do this. So we have 19 times that by 4. Now, if you notice, we're doing multiplication. In abacus, we don't do our math facts. You need to memorize your math facts. And your math facts that you need to memorize is 9 times 9. Go all the way up to here. Because after that, it will be called distributive property. Does anybody know what distributive property means? Whoa, that's a big terminology. Then I had to find that out. Distributive property. This is a math term that abacus never uses. But mainstream math uses this all the time. So what does distributive property mean? Distributive property means that we're going to take our information and we're going to count, we're going to multiply, from one, and then we go to the other. Now, before we start, we need to know where it's like grouping. Yep, it's kind of like grouping. So, and it's also a algebraic term, I believe. So, abacus is the gateway to more complex math. And what we do is in abacus is we lay a foundation. We laid the foundation. So the first thing we need to do is understand where are we going to start putting our answer. And the reason why we do is 1, 2, 3. We want to count our digits. When we count our digits, we know 1, 2, 3. This is where are we going to put our digits, right? Why? Because the abacus keeps track of our numbers. Oh, I remember. Yeah, right. That's what I'm saying. So we start at the beginning, but but in abacus we don't say distributive property. It's just a mainstream term. So we're going to count 1, 2, 3. So we're going to start here. So the answer might be around here. We kind of have to feel it. We're going to have to flexible, right? We're going to be flexible. So be open. Open your mind. Okay. Open your mind. So what we're going to do is we're going to do 4 times 1. We know 4 times 1 is equal to 4. So 4 is a single digit. There's a rule. If 4 is a single digit, I'm going to go back one column. I'm going to add the 4. That's all I'm going to do. Nuts. This is the wrong question, but that's okay. So when we do the 4, that's what I'm going to do. I'm going to add the 4. Now the question is, I want to add the 9. To add the 9, I'm sorry, to times 9 times 4 is equal to 36. So now this is the addition things that we needed to actually know before we get into multiplication. So what I need to do is I need to add the 3 in this column. When I add the 3 in this column, there's not enough beads. That is the question I need to answer. But if there's not enough beads, what are you going to do? Well, there's a formula in abacus that we're going to have to memorize, and that's when we utilize this 5. So in abacus world, we have this thing called plus the 5 minus the 2. So why are we doing that? Because we're going to add this 5, and when we add this 5, we have to take away 2 to balance it out. And then our final answer, we're going to add the 6. So my final answer is, who can tell me what this number is? I should figure out another abacus question. Who can tell me what number this is? 76. Thank you, kid. Yes. Hey, Josh, welcome back. Thank you. Naga, thank you. Thank you. I'm surprised Josh is back. Hey, Lando. Yes, perfect. 76. So it wasn't too bad, right? It wasn't too bad. Because, why? Because we can see it on the abacus. All right. So what's going to happen now? Okay, we're going to go back to doing some addition and subtraction. We're going to do some addition because we need to understand the basics. We need to understand the basics on how to do things. So the first thing we did is we understood. Thank you, guys. Thank you, Lando and Angelita. So what? Okay, so what we did here is we understood how to read the abacus, and this is the story. This is the activities that we were doing. Well, we didn't do it, but this is the idea. I'm new. Oh, very interesting. Thank you, Rome. I think I'm gonna have to call you Rome. Yes, thank you. So we will do a review before we start doing some. I'm sorry, I'm new here too. Oh, I was thinking of a different Josh. There was another Josh yesterday that came by. This is my first live. I've never worked with this, and just from my short time, I learned so much. Thank you so much. Okay, okay. So what we're doing is we're understanding how to read the abacus. But before I go into adding and subtracting, let me catch everybody up. So the first thing we're going to do is understand that in mainstream math, we focus on the result. But in abacus world, we do not. We focus on the add-in. So let's review a little bit about how to read the abacus for those newcomers. So in the chat, if you're new, type number 1, and I'll show you number 1. So everybody who's new here, type number 1. And what is it? It's 1. So this is what 1 looks like. Easy, right? Anything that's touching in the bottom, thank you guys, thank you. So any of the beads, so you guys are one bead, you guys are all touching this horizontal bar. This is the number 1. When we have 2, everybody type in 2 in the comments. Now you'll see that this is 2, 1, 2. Come on, we gotta speed it up a little bit, right? So we have 2. Make sense? 1, 2. Now if you notice, none of these beads are touching the horizontal bar. Thank you guys, thank you so much. So when we do 2, this is 2, this is 2. So if I do 2 on all of these columns, now all of these columns are being counted. Does that make sense? Because all of these columns are touching the horizontal bar. When they touch the horizontal bar, we are now counting them. So what does 3 look like? Whoa, that's what 3 looks like, right? And then after 3, we do 4. After 4, wait a minute. After 4, what happens? So everybody in the comment put in 5. Put in 5 in the comment. What does 5 look like? The 5 will always be the top bead. The 5 will always be here. Yes, thank you, Naga. Yes, the 5 will always be the top bead. Yes, blue, like LA blue. I don't know. I'm just add the 5, subtract the 4 for the 4. Yes, Lando, but you're jumping ahead. So when we add the 5, that's what it looks like. Notice I want to go to the horizontal bar. Does the row matter? No, the row doesn't matter. It just depends on where you label which one you call home. So that means that if I wanted to, I have my ones indicator. That's this thing right here. This is what tells me where the ones is. So because this is the ones, this is the ones, or this is the ones, like Pokemon. I choose you, but I choose this one to be my ones place. So if I look at it, it'll be my ones, my tens, my hundreds, my thousands, my 10,000. And the reason why is because now we have labels, and so it's easier to see. So I have my ones and my thousands. You could choose this one if you really wanted to, but then you would shift everything over, and this would be my ones and my tens. And then after that would be my decimals. Does that make sense? So what happens is it doesn't matter where you place. You just want to choose one home. And there's designated homes, like there's designated hotels, right? There's designated Airbnb. There's designated spots for the ones. You could do this. You could if you really wanted to be without a designated home, but then it gets confusing after a while. Jose, midnight, Matthew night. Does the color of the bead signify anything? That's a very good question, Michael. No, it doesn't matter. The reason why is because it's just the positioning. So this one is a 7-column abacus. This one is a 13-column abacus. So if you notice, I have multiple places for a home. So I have this, and this. So if I choose this to be my home, if I choose this Pokemon to be here, then I can count ones, thousands, millions, billions, and trillions. However, if you want to track the national debt, you would have to get a bigger abacus because size matters. This is a 23-column abacus, and again, it doesn't matter. It's 11 for me as long as it's nighttime. We're going to say midnight mething. Yeah. So where do you get the abacus? Where did you get an abacus? You're an abacus. What? Where did you get an abacus? Where did I get my abacus? I sell this one on my website. If you want it, you can get it. My website's in my bio. If you're looking for the 13-column one, and you're feeling a little inadequate, you can get it at Daiso. I got this one from Daiso, and I think you can get it for like you can get. Oh, I'm sorry, Lando. I'm so sorry. I'm so sorry. I, mm, I'm so sorry. That's my fault. Um, I was just reading the comments and I wasn't paying attention who the person was. I'm so sorry. But yeah, I don't know if you have a Daiso around your area. You might want to try the TikTok shop. I'm trying to figure out how to get my TikTok shop up. But I know other people from the TikTok store has sell these as well. And then if you notice, I believe they sell these ones, and this is made out of plastic. And then this is 13 columns. This one is a little bit more pricey, and I don't know. I don't know how much they sell it for. I know Daiso sells it for less than $4, but that's in America. This one I know they sell this one, but it's a little more pricey because it's a little, and this is made out of wood. I'm sorry, it's made out of bamboo. So what's going to happen is this one right here. This is made out of plastic. It all works the same. It works very well. It doesn't matter. It all works the same because the reason why we want to have it like neat, fast to move is because we want to be able to move the beads quickly. So going back to the question, does the colors matter? No, the colors doesn't matter. It's all about the positioning. So when we line it up, we have five. This is five. This is six. This is six. Does that make sense? So it doesn't matter about what the colors are. It just matters about the position of the beads. So let's count all the stars in the sky. Yeah. For me, it's about I've seen three more than yesterday. Oh, yay! 30. Jose, we're not there yet. We got to do some addition first because there's a lot of new people, and I want to make sure that we want to have a good foundation. There's no memorization here. So what we do is we need to understand how to move the beats. Let me write it down though. And 31 over 4, but then there's going to be a remainder. So we can do that in a little bit. So notice that when we do this, so did that make sense? So I've just kind of lost everybody. Oh, we could do that too. Uh, okay, we'll have to do that after we do the simple. Now, what are we doing is we're understanding how to move the beads. This is 1. When we look at it, we have 1, and this is 5. When I add the 5, I want to add the 1. The question is what am I doing? Why am I adding 1? The reason why we're adding 1 is because we want to see what the beads look like. When the beads move, notice I'm only moving the one bead. I'm moving the one bead like this. So if I want to add, I go to the horizontal bar. When I subtract, I go away from the horizontal bar. Thank you so much for the follow. So we have 5 and then we have 6, right? Because I'm going to the horizontal bar. That's what I did. So then what happens is if I have 7, 5, 6, 7, I want to add 1, I'm going to the horizontal bar. If I want to subtract, I go away from the horizontal bar. Does that make sense? So the positioning, the way we move our abacus is how we understand adding and subtracting. And that was one of the things that hey, Michael, I thought I would stop by. Hi, Michael, I've heard about you. Welcome. So when we work with it, let's say our next number is 2. Now, again, if you notice, we have a specific add-in. When we look at the add-in, we're always looking at the specific number that we are looking at. We're not memorizing the answers because it doesn't help to memorize the answers. It doesn't help how to make it. It matters on what we do to make the answer. Right. So it's not like I'm going to say, 5 plus 2 is equal to 7. I'm not going to do that. I'm going to be like, okay, if I have 5 and I want to add 2, I want to add 2. How do I add 2? So the question is always going to be, do I have enough? Can we do it? Yes, we can. So, hey, Lando, do you have Bob the Builder? So in like Bob the Builder, right? I want to add 2. Can we do it? Yes, we can. And that's what I would do. So the reason why we do that is because we have enough beads, right? Okay, good. My kids kind of saw Bob the Builder. So then we have this one. We have 6. After we have 6, we have 6, and I have 2. I want to add 2. Can we do it? Yes, we can. So we're going to add 2. So my final answer is 8. So what we're doing is we're understanding how to move the beads and what we're trying to do. When we have this is 5. I have my 5 and I want to add 3. Again, I'm going to add the 3. I'm going to go to the horizontal bar. When I want to subtract the 3, I go away from the horizontal bar. So now we know how to add. Now we know how to subtract. What's going to happen is we understand how to add and we want to understand how to subtract. And notice it is very similar. It's just the reverse. Whereas in mainstream math, it's very complicated. Thank you for the share, Colo. So again, what's after 4? What's after 3 is 4. After 4, there's not very many, right? What about adding two double digits? Oh, we can do it. We can do it. But let me go through the basics on the addition, and then we can go into double digits, and then we go into further into more when we talk about equations and stuff. So 4, there's only 4. That's it. So it's either 0 plus 4 or 5 plus 4. And that's 9. So 4 doesn't have a lot of questions. And again, notice if I have the add, I'm going to subtract. And that's what the next lesson was, right? The next lesson is to minus. So if I add 1, I can subtract the 1. So, oh, and then again, it's the minus 2. Well, what happened? We've done 0 to 4. Okay, that's fine. But now we do the next one, which is 5. 5 is the same way. We add the 5 or we take away the 5. So we know we're going to the bar for the horizontal bar. We go to the bar, we're adding. We go away from the bar, it's subtracting. So it doesn't matter if you're on the top or on the bottom. You go to the bar, it is adding. When you go away from the bar, it will always be subtracting. So what we did is we're adding the 6 or we take away the 6. We add the 7, we take away the 6, we're moving it away from from the center, from the horizontal bar. Does that make sense? Wow, thank you guys so much for the 11,000 likes. So what we're doing is we're just learning how to move the beads. Does that make sense? How long have you learned this? I've been doing this for more than 20 years. And so you can hit me any question, but I don't know if I can give you the answer. But thank you for the comment. Thank you for the question. Let me know if you have more questions about the abacus. Yeah, I've been doing this for about 20 years, but I just started, going online and showing my worksheets. And so all these worksheets I have that I'm still building. I'm still building a lot of my worksheets. So again, we have the 7 and then we have the adding of the 8 and then we have how do you use it? This is what I'm doing. I'm using it right now. So when we add the 5, when we take away the 5, so what does that mean? When I have 6, I have 6, 5, 6, and then wait, how do you show 10? Oh, very nice, very nice. So I have 6. I want to take away the 5. I'm going to take away the 5. So what's going to happen if I have 9? What's after 9? We have 10. Well, if you look, this is what 1 looks like, right? 10 just looks like that. Why? Because 10 is just as a place value because we have a 1 and a 0. Does that make sense? L.A. Dictora? Dictoria? Dictor. L.A. La Director. La Director. So that's why we have our place values. We have our 1 and our 0. So we have 20, 30, 40, and then 50. And then I don't know if Brax is still around. So, oh, yes, yes. So the top bead will always be 5. So when we look, we have 1, 2, 3, 4. When we do 5, this will be 5. This will always be 5. But notice if I have 1 and I add the 5, now I have 6, right? So if I have 2 and I add the 5, now I have 7. And then what is it? If I have 3 and I add the 5, now I have 8. When I have 4 and I add the 5, now I have 9. Is this meant for teaching addition to children or some sort of mechanical? Yes, Soggy Sizzler. Yes, that actually makes a lot of sense. I've always wondered how to use it. Can you do subtraction? Yes, you can do subtraction. You can do subtraction, multiplication, and division, and addition, and decimals. But decimals is really just another column. And it's really interesting because abacus makes it such a manageable thing. Abacus goes way back in time. Yes, it does. Yes, it does. It goes right around the time after they did bartering. Fractions is just another term for division. So, can you teach us division? I can teach you division, but I don't know if you guys would get confused because we got to go through the foundation first. We got to go through adding and subtracting, and then after that, we could do multiplication, and then we'll do division. When it comes to adding with doubles, do you use the distributive property? No, no. When I do the doubles, I actually do not. What I do would be if I had um, 31 plus 3. Oh, no, let me do double digits. Okay, let's do that, right? So what I would do is not distributive property because in addition we don't do distributive property. We only do distributive property for multiplication and division. I think it's only a multiplication thing. So if I add 31, I have 30 and I want to add the 1. So then my next question is what? Have a good night, director. So when I add the 1, when I start adding, I'm going to add my left to my right. So I add 1 and then 3. So my final answer is 44. Does that make sense? So when I look at it, I do the whole thing. I don't start from here. I start from here. This is where I start from. So when I look at it, we can do another one, right? We can do 17 plus 71. I don't know. I'm just okay. So we're gonna do 17. We add the 1. We add the 7. Now in regular. Hello, Will. So in regular math, we're going to do the ones, but in abacus, we actually do the left first. So we're going to add, is there enough beads to add the 7? Yes, there is. How do I know? Because I have 5, 6, 7. So I'm going to add 7 like that. And then I need to add the 1. When I add the 1, I just need to add the 1 bead. So my final answer is 88. Yes. Can you show? Yes, I can. But now we're going to go into, yeah, it makes sense because you could see it. So the first thing we're going to do, yeah, we could do that. That's not a problem. YT narrow waveform. Okay, cool. So the first thing we're going to do is we're going to understand when we do 4 plus 2, 40 plus 2, right? That's how the thing. But now we're getting into a part where we need to start looking at our formulas. Because the question is what happens when there's not enough beads? Well, we have a thing in school. Do you know? I don't know. Does everybody know how to do this? Do you remember how to make a 5? This is what we're teaching children how to make a 5. You need to learn how to make a 5. Does that make sense? Does anybody know how to make a 5? Do you guys know how to make a 5? Why narrow way? Do you know how to make a 5? This is what they're teaching in school, right? And so that's fine. But abacus actually takes it one step further. Why? Because abacus, we don't memorize our doubles. We don't memorize doubles. We don't memorize 4 plus 4. We don't memorize 4 plus 4 is 8. We don't memorize anything. What we do is we utilize the beads. The beads is what helps us think about it and we critically understand. So the first thing we're going to do is understand that I need to add the 3. Yeah, right? Oh, good. So you're going to like this because what happens is when I want to add the 3, notice I don't have enough beads to add the 3. So what am I doing? I know that this is my pair. What I need to do is I need to take it and I'm going to modify it. You bring down and subtract the other beads. Yes, Lando, yes. So what are we going to do? We are going to use this thing called, in abacus world, we call it formulas. We need to add the 3. So the first thing we're going to do is we're going to understand how to add the 3. What we're going to do, we have this concept. So let me show you how to make this concept work for us. So what's going to happen is I have this concept, 4 plus 1 is equal to 5. I was like, great, okay. Do I tutor? 11-year-old needs so much help. I tutor abacus. If she wants to learn, if you want me to teach her abacus, I do it. If you want to hit me up by my DM, we can talk about it. What is an abacus? An abacus is the original calculator. It's a manual calculator, and it's one of those things that help us understand stuff, understand how to add and subtract. Yes. Okay, yeah, send me a DM and we can talk about it. We can talk about it offline. But yeah, and so what we're going to do here is we're going to isolate the variable. When we isolate the variable, what does that mean? Well, the question was what? The question was, oh, I'm the wrong one. I'm sorry. I'm sorry. I don't mean to confuse people. There you go. No, no, no. We got to do the 3. We got to do the 3. I'm sorry. Wrong one. It's 3 plus 2 is equal to 5. Why? Why? Because the question is right here. This is the question we're trying to answer. We're trying to answer 4 plus 3. So what we're going to do is we're going to do 4, and notice I don't have enough beads to add the 3. Because I don't have enough beads to add the 3, I have this concept that I'm going to manipulate and work for me. So I'm going to isolate this variable. I'm going to do 3 is equal to 5. Why am I going to do that? The reason why is because I want to utilize this 5. Because I utilize this 5, this method can be used for multiplication and division. In multiplication, you have many beads in the one position. What if it's over 9? Well, it's the same. Okay, wait, I'm sorry. Let me finish my thought. So if I have the 5, I want to add the 5, and then what I need to do is that's too much, right? So what I have to do is I have to minus the 2. When I minus the 2, my final answer is 7. So what's going to happen is I have 7 over here. Does that make sense? So what we're doing is we're utilizing this concept that we're already teaching, that we already learned how to do it. But now we're actually going to make it work. We don't want any we don't want any freeloading numbers, right? No freeloading numbers. No freeloading numbers. I'm going to protest about this. Now, if you look, we do the next one. The next one is to add the 4. Oh, sorry. So if I have my 4 and I have my 3, I'm going to plus the 5 minus the 2. So that's what I have here. And oh, I'm sorry, I have to have the 2. So this is my 40. Sorry. So I have 42, and my question is to add the 3. When I add the 3, I plus the 5, take away the 2. Okay, good. So now I have the 4. When I have the 4, I know my concept. This concept is plus the 4 is equal to plus the 5 minus 1. How do I know? Because if I look, plus 4 and 1 is this, right? And then what do I need to do is I need to isolate this variable. So it'd be 4 is equal to 5, but 5 is too much, so I have to take away the 1. So now I can make this work. I plus the 5 and I take away the 1. Does that make sense? So my final answer is 76. So what I did was I just showed how to use the abacus for adding and subtracting. Yeah, because now we're building on our foundation. 76. So TKG4 is multiplication. In multiplication, if you have too many beads on one position, what would you do if it's over 9? Well, it's the same thing. What are you going to do when there's 2 digit, right? So it's just the way we talk. When we have after 9 is what? As a 10 is a 2 digit, which is 10. Does that make sense? So the question is anything over 9, it becomes a distributive property. So if we do 13, right? If we do 9 times 13, it's a distributive property. Or 13 times that by 9, it would still be distributive property. It'd still be 9 times 1 and then 9 times 3. Does that make sense? So anytime we go, even if we did 10, it'd still be a distributive property no matter what. So in abacus, we actually do distributive property. This is a very common thing in multiplication. But yes, we can do multiplication and division on the abacus. Does that make sense? So we understand this. Does that make sense? We understand how to add 5. So the big thing is once we know how to add the 5, we want to take away. When we take away, why are we going to take away? Well, we're going to take away because we need to take away. But in school, we're teaching children how to do many ways to take away. But in abacus, we actually do the opposite. So adding for the 3, let's say I have 7. If I have 7 and I want to take away the 3, I don't have any beats to take away the 3. So my question is 7 minus 3. That's the question. I know my concept. My concept is minus the 3 minus 2 equals to minus 5. If that's okay, then what's going to happen is we're going to isolate our variable and we do minus 3 equals to minus 5. Again, this is too much. So what are we going to do? Audrey, go to bed, Audrey. So what's going to happen is I got to add the 2. So I have to add 2 to each side. When I do this, now I can manipulate my question. I can take away. So I have my 7 and I have to take away 3. But to take away the 3, I'm going to minus the 5 and I'm going to add the 2. So it's very visual. And that is why we do it. That's why we do certain things. And we understand. But see, that's the thing, right? The thing is we take this to the next level. We don't just memorize this. We understand it and we utilize it. Whoa. Is that all right? Does anybody have any questions? Whew. Okay. It's 2 a.m. I have to go. Yeah, Lando, go to bed. You know what? I'll see you in the morning. I'll probably be on tomorrow morning. I'm gonna try to be on tomorrow morning, probably, I don't know, maybe 8 or 9 my time. That would be Pacific Standard Time. Great, Gab. Great. So what we're doing is we're understanding how to utilize our concepts. Our concepts is this. Thank you, Lando. Ah, whew, so funny. You guys are so funny. In the middle of the night, learning math on your own because you want to be here. So that's why we understand this, right? We took this and we took it to the next level, right? Where it's no longer just kind of sitting around understanding this information. It's wait, this is so fun. Lazy Lux. I don't understand math at all, but I enjoy this so much. Really? This is But if you understand this, then you're understanding math. So that's the thing, right? Like we are teaching children how to do that, and so we take it to the next level. And when we take it to the next level, it's a lot easier. And then what's going to happen? Well, what's going to happen? Guess what? There's one more step. That next step is to make a 10. We teach children how to make a 10, right? We know how to do it. We know how to make a 10. But making a 10 so hard, it's not hard. You'll see. You'll see. So the first thing we'll do is, why are we going to make a 10? Well, why do we do it in the first place? Because we do a carryover. Remember when we carry over? Remember carrying over? What is it? Carrying over and borrowing? We did all of that stuff. So let's do 8. If I did 8, I do 7 plus 8. Okay? 7 plus 8. 8, where's my little cardy thingy? 8 is what? What's the partner of 8? So everybody in the chat, can you put down the partner of 8? What's the partner of 8? We know this. What's the partner of 8? So if I did 8 plus, yes, thank you. Thank you, Romario. Yes, minus and then plus the 2. So what we're going to do is we have this concept. We know how to do the partner of 8. Well, what do? We're going to isolate this variable. So that means 8 is equal to 10. And then what happens? 10 is too much. I'm going to minus the 2. So here's the question is 7. I have 7 on my abacus. Oh, you can't see that. I have 7 on my abacus. When I have 7 on my abacus, I want to add the 8. What do? I need to plus the 10 and then take away the 2. Now, if you look, adding the 10 just means 0, 1. So I add the 1 here and I take away the 2 and I can take away the 2. My final answer is 15. Thank you so much for the comments. Yes, right? Does that make sense? So what are we doing? We're taking our concept and yes, easy. It is 15. 1 and 5. All the top beads is a value of 5. All the bottom beads has a value of 1. So when we look, this is 15. Then we could do 25, 35, 45. And then after 45, we have 55. So all of these two beads are 55. This would be 55. But my final answer is 15. Exactly. See? Easy. Easy. Anybody have any questions? So what are we learning? We just learned how to add the 5 and we learned how to take away the 5. Add the 5 and add the 10. These are the core concepts of adding and subtracting. When you understand this, then you understand it all. Yep. Every math question that adds and subtract sits on these two concepts. That was a mind blowing for me. So, yes. Anybody? Woohoo! Yeah. Okay. Let's do it. Romario. Okay. So we know how to add and subtract. Okay, so we know how to add and subtract. I'm going to put these away. Would you be able to isolate the 7? Yes. Yes, we can. Let me show you how to isolate the 7. It's exactly the same. It's exactly the same. There's a whole thing on it. So we have this one, right? We have this one, which is 9. We've done 9. No, we didn't do 9. We did 8. We did 8. We can do, let's see, subtract. Where is, okay, we did this one, 2, 3. Here, 8. So, sorry, just trying to find my papers. 6, 7, 8. There we go. So here it is. Here is 7. What we're trying to do is we're trying to add the 7. When we add the 7, let's do a question, right? The question is 9 plus 7. When we do 9 plus 7, before I forget, I got to put in 49 plus 40, 80, sorry, 94, 94 plus 27. Right. I have it in my mind, but I want to make sure we got it. Yeah, I want to make sure I got it too. So, would it matter what you choose to isolate? It matters what you're trying to do. So if I'm adding a 7, right? The question is 9 plus 7. It's the add-in, right? So 9 plus 7. I want to isolate this number. So I want to know how to do it. My concept is 7 plus 3 is equal to 10. So what I can do is I can do 7 equals plus the 10, and that's too much. I need to minus the 3. So here it says make the 7 by itself. We need to subtract 3 from each side. So what we do is when we write it, we want to write it, we can write the commutative property. So that means if I want to add the 7, I can plus the 10 minus the 3, or I can plus the 7 equals minus the 3 plus the 10. This is the same. So when we do it, we want to add the 7. When we want to add the 7, I can minus the 3. So I'm going to minus the 3. And then remember, I want to add the 10. To add the 10, it's 0, 1. This is 1, so I'm going to add the 1. So my final answer is 16. So yes, we can isolate. And then if you notice, is the abacus really fun to use than the calculator? I think it is. Bingo, I got it. Yeah. So when we look at it, these are all the numbers that you can isolate. So you can isolate any of these numbers and this. So it doesn't matter, but what matters is how are you going to use it and what is it for? Does that make sense? Yeah. Yeah, it's all about the specific number you're using. And that's why I said what we do is we focus on the add-in. We focus on the number we're trying to add. We're not focusing on the result. And so I know in school we always say, "Oh, how do you make an 8?" No, 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 no. No, not how you make an 8. It's what's the question to make the 8, right? And so like here's our question. We have 94. I'm going to put 94 on the abacus. 94. And then when I do it, right? When we go through abacus, we do left first and then we do right. So we do left, right. Okay? We always start from the left, just like how we count, just like how we talk, right? We read left to right. So we say 27, not 720. So when we do it, we go from left to right. And that's why when we were doing it, we want to make sure we understand what we're doing. So I want to add the 2. Now the question is always, can I add the 5? That's the question. I'm sorry. The first question is, do I have enough? No, I don't. So then what do? I see, can I add the 5? No, I can't because I'm using it already. I cannot add another 5. What can I do? I can add a 10. So to add the 10 is what? Trying to find it. Subtracting. Oh, here it is. So, okay, now I want to add the 2. So I'm trying to add the 2. Here is my sheet. This is what I'm trying to do. I want to isolate my variable. right? I want to add the 2. There's not enough beads to add the 2, so we can utilize the 10 bead on the left. So the 10 bead is on the left. That's what this is. Where am I? Oh, 9. We did the 9. So that's what this is. So it doesn't matter. It's the formulas are position agnostic, meaning that it doesn't matter where we're going to do. We're always going to say 10 plus the 10. So what that means is we're going to isolate the 2. Why are we going to do it? Because the question is 2. So when we isolate this 2, we need to know that 2 is equal to 10 minus 8. So what we need to do is we need to make 2 by itself, and then we need to subtract 8 from each side of the equation. When we do that, this is the equation I have. I can say 2 is equal to plus the 10 minus 8, or I can say 2 is equal to minus 8 plus the 10. This is a commutative property. That means I can switch it around. So let's do that first. Let's do minus the 8 and then plus the 10. That means a 0 and a 1. 0, 1. So 1 goes here. Does that make sense? So what's my next question? My next question is the 7. So what do we do? Is there enough beats to add the 7? No, there isn't. So do we know how to isolate the 7? We do. I did it before. Where is my paper? When we in the chat, do you remember how to how to isolate the 7? Because what we're doing is if we don't have enough beats to add the 7, how do we add the 7? Let's see who can tell me what it is in the chat before I find my paper. So I'm just trying to find my paper. I have this one. This is subtraction. Oh, I'm getting close. I don't know. No, Gabby, you got it. So 7 plus 3. So when we do 7 plus 3, we are going to isolate the variable, right? We're going to isolate the 7. When we isolate the 7, right? We isolate the 7. We isolate the 7. It's plus the 10 minus the 3. Yes, thank you, Rome. So when we do it, we want to plus the 10, take away the 3. Remember, I'm going to take away the 3, right? I'm going to take away the 3. I'm going to plus the 10. Plus the 10 just means a 0 and a 1. I'm going to add the 1 here. So I'm going to add the 1. So my final answer is, what's my final answer? Yes, 1, 2, 1. Make sense? I want to... Yeah, perfect. Yeah, perfecto. Yeah. Right? It's easy, right? So the biggest thing is understanding of all of the formulas that we have. Because we understand our formulas, then it'll be easy to understand how to add and subtract. And now, right? Oh, good. Fantastic. So let's do some more. Let's do a couple of more. Now we're going to do double digit. So if you look, easy, does that make sense? Are you okay? I'm just looking through my papers because I need to, what I needed to do. Yep. Okay. So I'm just cleaning up a little bit because I want to make sure I get to my, okay. So now, easy, the AV, I don't know what the AV is. Okay. So what are we going to do? Now, the first thing we're going to do, okay, we understand that we need these two formulas, right? Because we need these two formulas. But now the question is what's going to happen when we need more? We don't need more. What's going to happen is when we understand that now we get what they call it is a two-step equation. So what we're going to do is we're going to understand what a two-step equation is. A two-step equation. What does that mean? It means we're going to actually start doing is understanding how to Tetris our foundation. When we Tetris our foundation, it means that we're going to actually make this work better. Can you teach integrals next? Hey, Tyler, I don't know what integrals are. That's above my pay grade. But if you're looking for someone to teach you integrals, I know a person and you can DM me and I will send you the person that does integrals. I believe she does integrals. I don't know if is that an algebraic term? Because I don't know. I'm simple folk. I only know adding and subtracting. So the first thing we're going to do is it's calculus. Ah, sorry. That's above my pay grade. I don't know anybody who does calculus. The first thing we're going to do is understand 7 plus 7. Again, we're not going to memorize this, right? We're not going to memorize 7 plus 7. What we're going to do is we're going to think our way through. Sorry, Tyler. I'm a simpleton. I don't know fancy stuff like that. So the first thing we're going to do is we're going to do 7. When we add the 7, right? That's the first one. Now we got to do the second one. Remember our formula. Our formula is this. Oh, have a good night. Yeah. Have a good night. Good luck. So we have 7 is equal to plus the 10 minus the 3. Remember that, right? It's getting late, but I really enjoy listening and learning. I learned a lot. Oh yeah, thank you, Gabby. Yeah, you know what? Have a good night. I'll see you in my next live. Thank you for the follow. Thank you for commenting. I do appreciate all the comments and questions because it's very helpful to see where everybody is. So the first thing we're going to do is understand how to do this. What does that mean? Well, if we look, we have the 10. We're going to plus the 10. When we add the 10, remember it's a 1 and a 0. We add the 1, right? And then we're going to do is we're going to minus the 3. Notice we cannot minus the 3. If you remember how to minus the 3, we can utilize our 5. When we do that, we need to minus the 3 is equal to minus the 5 plus the 2. Thank you for the follow. Why are we doing that? Because we can utilize this 5. We can minus the 5 and we can add the 2. This is now what we call a two-step equation because this and this gets substituted into here. This is why it's called a two-step. So my final answer is 14. Wow, that's crazy. 12,000 likes. That's what we're doing. That's what it is. It's all about that. Anybody have any questions? Remove. Okay, are we okay? So what we're doing is we're doing a two-step equation. We have a lot of, yes, 72, 72. That was a while ago, 72. I'm still here. The little cheat sheet is great. Great. I'm so happy you're still here. Dan, I don't know what 72 is. 72. I don't know what 72. Okay. So, yes. Yeah, the little, because we've learned this, right? There's a little flippy thingy, and I actually do this one. And it tells us how to work it. So when we go, we want to add the 2, we want to minus the 5 and plus the 3. If we want to add the 3, we want to plus the 5 minus 2. If I want to plus the 4, I want to plus the 5 minus 1. Now, see, the thing is we can get into more two-step because it gets a little bit more complicated, or we can start going into multiplication and division. Hello, Blue Raptor. Welcome back. So what we could do is we could do more two-step equations because I think it's a little bit underrated to understand adding and subtracting. So the one of them is like 49 plus 5. Now, why is this going to be hairy? Well, if you look, I have 49. I have 49 on my abacus. Hey, Dan, if you have any questions, let me know. Oh, that was like an hour ago. Woo! Okay. So 49. When we're going to add the 5, we're going to add the 5 here. When we add the 5, what are we going to do? Well, that's where this little doohickey that I've been trying to make. So we're going to add the 5. We're going to make the 5 right here, right? We're going to add the 5. We don't have enough beads to add the 5. So what do? We know to plus the 5, we need to plus the 10 minus the 5. But again, let's do it the other way, right? We can also do minus the 5 plus the 10. Why? Because let's take away the 5. We take away the 5. And then what do? We have to plus the 10. Notice the 10 is a 0 and a 1. 0 and 1. When do we have enough beats to add the 1? No, we don't have enough beats to add the 1. What can we do? To add the 1, we know that we're going to plus the 5 minus the 4. We're going to plus the 5 and take away the 4. So my final answer is 54. Does that make sense? Yeah. Yeah. I'm happy you're still here. Okay. So that is a little bit about two-step. Yeah. And this is all the information you need. As long as you understand how to critically think every step, then you're golden. So it's always about the individual steps. So notice what I did was I did a two-step over here. What was the two-step? This one was the two-step because I didn't have any more beads to add the 1. Thank you so much for the likes. So I didn't have enough beads to add the 1. What can I do? Well, plus the 1 is equal to plus the 5 minus the 4. So that was another step that we just did, right? But we knew this. We know how to make a 5. Thank you so much for the likes. Okay. So those of you that just came in, put in the chat if you one if you're new, two I know you're here. So put 1 if you're new here. So I'm hoping that makes sense. And then we can actually go into multiplication division. Are we ready for that? We can do that. I don't know how many other people are still here, but we can do that if you want to. Okay. Cool. 2. Hey, crazy. Okay, so it is multiplication. So again, for multiplication, we can do it, right? And we understand we're going to understand we're going to understand distributive property, right? So distributive property, so it doesn't actually matter what the numbers are. We could do now it doesn't matter. We could do 45 times that by 8, right? Hey, Tyler, I don't understand the use of this. Would it not be easier to count? You could count, or the abacus can help you. So, when we're counting, so I mean, you could count, right? You can count 45. I'm sorry, 40, 49. You can count 49, and then I know that this is 50, and then 51, 52, 53, 54. You could do that. No, 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 no. No, 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 no. You're not being rude. I understand. So I mean, there's many ways to do adding and subtracting, right? I know there's a number line. So some people will say, just draw a number line. You could do a number line. You could do that. But see, the thing is the number line only goes so far. Oh, sorry, it's supposed to be 49. So I do 49, go 1, 2, 3, 4, 5. And then it would be 50, 51, 52, 53, 54. You could do it, not a problem. But what happens when the numbers get bigger? Right? So that's what I'm trying to do. The abacus is an old, but she's trying to explain the abacus use and it has its own rules. Yes. So let's do a bigger number. If we do a bigger number, like let's do this one, right? If we do this number, Tyler, right? 2,763. We could do it. Do you want to count ahead? You can do that too. Not a problem. But it is what it is. And so when we do this, right? When we do this on the abacus, it's the bigger number. So what we're doing is I'm showing you the fundamental and then we can scale it. So what we're doing is we're scaling it. So here's the question. We do 2,763, right? And then when we add it, we have 8. We add the 8. Notice when we add the 8, we want to plus the 10 minus the 2. I don't know how you do this in new math. I only know how to do an abacus. So I'm going to plus the 10 and take away the 2. I'm going to add the 9. To add the 9, it's plus the 10 minus the 1. I'm going to plus the 10 minus the 1. When I add the 4, can I add the 4? Right? What I want to do is I want to add the 4. I want to add the 4 here. I'm over here. I want to add the 4. When I add the 4, what am I doing? I want to plus the 10 minus the 6. I'm going to plus the 10, take away the 6. And then I go here. I want to plus the 5. When I add the 5, All I got to do I have enough? Yes, I do. So what my answer will be is 11,708. Do I teach kids? Yes, I do teach kids. I do teach kids. And you want to DM me, we can talk about it. I do offer online on demand classes. Like I said, it was a genuine question. I wasn't being No, you're not being rude at all. You Tyler, you'd be rude if you said I was a horrible teacher. But does it make sense? So now what we could do is understanding these rules, we can actually scale it. Does that make sense? There's no harm. There's no harm. I'm okay. It's okay. We're all okay. It makes sense because there's a lot of people that don't understand, and I understand that. So, does that make sense? Oh, thank you. Understood. You're good. Yeah, we're all good. I'm okay. We're all okay. We're good. We're good. No offense taken. No offense. Okay? Yeah, no, no, I understand, but it's okay. We're all because you guys are talking through text, so we don't know what the tone is. It's okay. Please, please. No fighting, no fighting. But yeah, thank you. Yeah, if you want to oboe, you can DM me and we can talk about it. So Tyler, did that make sense? Text Yeah, yeah. You know what? Yesterday, somebody said, of course, the Asian was the one that has to teach the abacus, and they used mazes. And I'm like, of course, you're stating the obvious. And he was actually trying to be mean, and I'm like, you're stating the obvious. I know I'm Asian. Okay. So Tyler, did that make sense? So when I do these things, right? It seems like it's overkill when we talk about just the single numbers, but when we start adding it to larger numbers, it makes a lot of sense. Like the strategies that we're teaching the kids, like doing number lines, doing the what do you call it? The bars and the stuff, or like even the box model, it gets a little overwhelming. And that's how I see it. I see it, it's a little overwhelming. And I like to simplify as much as I can. So when we do this, I don't do the box model. Like I don't even know how to do box model for adding and subtracting. So if you can tell me, that'd be great. But I don't know how to do box model to do this. But what I know how to do it in the abacus, and this is what I know. I've never seen an abacus. It's pretty cool. Thanks. Yeah, yeah, yeah. Not a problem. So, why do we do this? Usually, in the beginning, I was thinking that I'd be teaching young kids to learn how to do the abacus, but then as I have on TikTok live and stuff, and everybody comes in, and people are, and you guys are all adults, it's been interesting to see the journey that even older people wants to learn how to use the abacus, because one, it's like mental gymnastics. So you know how we do sudoku, we could do word searches, we could do crossword puzzles. I'm going to start adding in abacus would be a great thing to. It is, I've seen it, I've never had been explained before. Yeah. um so what I'm actually doing is I'm in the process of creating a introduction to abacus for adults. And so it would be forward prose. You can save paper space. You don't juggle as much numbers in your head. Yes. Yes. That's the funny thing. Well, it was like what did they say? Mental labor. Oh, yes. Yes, Machi. So in school, the only new math I can show you is when we were doing multiplication. So the only new math I know in that I understood. So one of the things was we did the one of the videos that I saw, they were doing new math, and it was like 370 times that by 400 738, right? And so when you do that, oh, have a good night, Tyler. See you later. So this was like the whole thing, and I was like, oh my god, where am I don't know. I got to do this one. So on the abacus, we know how to do it. What we do is we need to count the numbers: one, two, three, four, five, six. 1, 2, 3, 4, 5, 6. So we're going to start here. Now in abacus, right? 1, 2, 3, 4, 5, 6. What we're going to do is we're going to go left to right. That's a long abacus. Yeah. So we're going to go left to right. So the first thing we're going to do is we're going to understand 7 times 3 is equal to 21. So notice I say 7 times 3 is equal to 21. That's right? Yeah, size matters. So remember, so in school, there's the new math. What did they do? They do 300 times that by 700. And I'm like, oh. That's like, I don't, this is a lot. And I noticed the reason why they do this is because they need to write it out, right? New math is all about writing it out. Whereas on the abacus, it will track it for us. 1, 2, 3, 4, 5, 6. I'm going to add the 20. I'm going to add the 1. I don't need to say, oh my gosh, 1, 2, 3, 4, 5, 6. I don't need, oh, did I do that wrong? Oh yeah, I did that wrong. See, even this is wrong. So here, I don't need to track it because my abacus tracks it for me. Does that make sense? So now when I go to the next one, I'm over here. I do 7 times 4. 7 times 4, 7 times 4 is equal to 28. I add 20, I add 8. And then 7 times 7. 7 times 7 is equal to 49. I add my 4. Oh my God, you can't see it. I add my 4. I add my 9. I add my 4. I cannot add the 4. What do? Plus the 4 is equal to plus the 10 minus the 6. So I plus the 10 and I take away the 6. And then I add my 9. But see, the difference is we don't need to do this. We don't need to do 700 times that by 40. And then we don't need to say 700 times that by 7. We don't need to do any of this stuff. Abacus does it. This is manageable chunks for me. And I just need to know what my multiplication facts are. So I'm done with the I'm done with the 7. What do? I need to do the 3. So I count 1, 2, 3, 4, 5. Same thing. Wait, where are the tens on the abacus? The tens is always going to be the column to the left. Now we're talking about being position agnostic. Just need to understand the concept. So, okay, let's go back. So when we did this one, right? 1, 2, 3, 4, 5, 6. So we did 21 and then 28 and then 49. 49. When you look, we want to do 4, we want to do 9. This is where the tens come in. 49. Do I have enough to add the 4? I have an 8 here. Do I have enough to, I'm sorry, do I have enough, I'm sorry, 8. Do I have enough to add the 4? No, I don't. So what do? This is where my little contraption comes in. My question is can I add the 4? No, I can't. So what do? I have to plus the 10 and then take away the 6. Does that make sense, Machi? I plus the 10, take away the 6. 10 is what? 0, 1. 0, 1. So this is my 1, and I need to take away the 6. Take away 1, take away 6. And then I have to add the 9. Then I add my 9. Did that make sense, Machi? Oh, yeah, I was just wondering where the main... Oh, yeah. So my main dot is right here. I counted right in the middle. Yeah. So it'd be 1, 2, 3, 4, 5, 6. Yeah, sorry. That was my fault. Because I'm on a 13 column one, I usually start in the middle. Yeah. Sometimes I forget like how quickly I talk. So we're done with the 7, right? Now we do the 3. 1, 2, ooh, sorry. 1, 2, 3, 4, 5. So we got to go 5. 1, 2, 3, 4, 5. So now we're over here. Okay. Okay. I just making sure. So 3 times 3 is equal to 9. 9 is a single digit. Oh, sorry. 9 is a single digit. I go back one column, I add the 9. I'm going to add the 9 here. Is there enough beats to add the 9? No, there isn't. What do? Plus the 9 is equal to plus the 10 minus the 1. Well, let's minus the 1, and I want to plus the 10. Cannot add the 10, right? Cannot 0, 1. Cannot add the 1. Right. But I can't add the 1 here. What do? I have to plus the 5 minus the 4. Okay, good. We're done with the 3, right? So I'm here. 3 times 4 is what? 3 times 4 is 12. I add my 1, I add my 2. I add 1, I add 2. Do I have enough beads to add 2? I don't have enough beads to add the 2. What is my formula to add the 2? Oh, the other one. Why? Because I already have the 5 and I can't add a 5 again. So my next one is 10 minus 8. So I'm going to minus the 8 and I'm going to add the 10. And I add my 10. Okay? And then I'm still here. So my final my next question is 3 times 7. 3 times 7 is 21. Oh, we did that already. So I had my 20, I had my 1. So I had 20, I had 1. All right, we're done. No, we're not done. We have one more. We have one more. When we count it, 1, 2, 3, 4. Why? Because we've already finished our 3. So our next one is 4. 1, 2, 3, 4. So the first thing we're going to do is 8 times 3. 8 times 3 is equal to 24. Add my 2, add my 4. Add my 2 plus the 5 minus the 3. Add my 4 plus the 5 minus the 1. And then 8 times 4. 8 times 4 is, what's 8 times 4? 32. 32. Plus the 3 plus the 2 plus the 3. There's not enough. Plus the 10 minus the 7 plus the 2. And then our final one is 8 times 7 is 50. Is it 56? 56. Add the 5, add the 6. Where do you get the number for how many columns you start from? 56, yeah. Oh, you know what I did? Is I counted the digits. 1, 2, 3, 4, 5, 6. That's why I moved to the bigger number. Oh, my final answer is 2, 5, 6, 0, 8, 6. 1, 2, 3. I think that's what it is. Yeah, that's what I did. So what I did to figure out the number is you just look at the question. Yeah. Yeah, that's a good question. Whew, there's still 12 people in the room. Miru, welcome back. I don't know if it's right. Let me see if it's right. It's late. I have an excuse. 4, 7 times that by 7, 3, 8. Is that correct? Yes, it's correct. What order do you go from? We always go from left to right. So when we do it, we always go from left to right. So let me rewrite it. Right? 3, 4, 7 times that by 7, 3, 8. So when we do it, we always go from left. We always go from left first. So we go left and then we move it like this. That's what we're doing. And then we do that. Does that make sense? So then when we're done with this, we can do another one. We do another one. Let's do another one. Right? We're ready for the 3. When we do the 3, we cross this out, right? When we're done, we do the same thing. Left to right. Then you move. Yes, exactly. So you have to count. So we're done with the 7, you have to count. 1, 2, 3, 4, 5. Yeah. You always have to reassess what your numbers are. Those are really good questions. Does that make sense? Yeah. So when we're done with the 3, right, we cross it out, we got to reassess. 1, 2, 3, 4. You can move it down, but sometimes it's nice to know what number it is. Yeah. I hope that makes sense. Yeah. Cool? But see, that's what I'm saying. So using the abacus, it helps scale. And it gets it, when the numbers get a little hairy, and I think that's the difference, is like in mainstream math we don't have really difficult arithmetic questions. What we do, so every calculation for each numbers is put in their own columns. Exactly. Every number has a home. Every number has a position in the thing. It does. Just multiplication takes a few steps. Yes, multiplication takes a few steps, but I feel like it's easier to manage and you don't have to worry about the zeros, right? Because notice these are all math facts. We don't have to say 30 times 40 because there's no multiplication table for that. So what we do is we take it down to the bare basics, to the fundamentals, and then we just kind of slot it through like um not like a puzzle, more I feel like it's more like Tetris, if that makes sense. So yes, Machi, every number has a column. I'm sorry. Every number has a column. So there's always going to be a home for each number. Can we do another multiplication problem? Of course we can. Do you want to tell me another multiplication question, or do you want me to think of something out of my head? But yeah, and it's easy, right? Yeah. It has their own columns or their own tenths. Interesting, tenth is only meaning the next column over. So that's why we call it column agnostic. So if we had 900 and I want to add the 10, there's not enough. What do I do? Plus the 1 is equal to plus the 10 minus 9. So if I want to add 1 here, what do I do? All I got to do is go to the next column over. Why? 0, 1. This is 10. 0, 1. So I want to go plus the 10, plus the 1, and then minus the 9. So then my final answer is 1,000. Something similar. All right. Okay. I will change my... Let's see. uh, we'll do that. Okay, we'll do this. Something similar. So 6 digits is what you're looking for. I don't think we went over multiplication the last time I was here. I don't know. It always depends on the class, right? If some people get it, then we will go through. I've been to a point where the people have come so often that we have enough time to do division until I peter out, until my energy kind of like zaps me out. Because doing something like this, like after an hour and a half of live and then do something like this, when I get it wrong, that's when I know I have to go to bed. All right, but I still got good energy, so I think we're okay. So let's do, I don't know, 5, 3, 7 times that by 9, 4, 2. All right. This is still, maybe if I did this, maybe if I did that. What if I did that? So 6 places out. Yes, exactly. 6 places out. So when we look at it, 1, 2, 3, 4, 5, 6. I'm going to start in the middle. 1, 2, 3, 4, 5, 6. So I'm over here. I'm going to use this as my middle. Okay. So the first thing we're going to do is 9 times 5. 45 is it? Yes, exactly. So we're going to do 40, we do 5. 9 times 3. 9 times 3 is 27. Right. I like to write it down because if I forget because sometimes I lose track. So 27, 20, and then add 7. I'm going to add 7. And then 9 times 7. Yes, we add 27. Yes, exactly. But notice, okay, wait, before I go, notice 40, okay, 9 times 5 is equal to 45. Notice I do 40 and I do 5. My finger stays here. When my finger stays here, then I add 27. 27. And then I have 63. I add 6, I add 3. Yeah. So that's the one thing I keep forgetting to let you know. 63. Yes. Thank you. Times that by 7 times 63. So the first thing I'm going to do is I'm going to add 63. I'm going to add the 6 here. So you're always descending. Yeah, you're always going down to the next column. So I want to add 6. When I add the 6, I can't do it. Plus the 6 is plus the 10 minus the 4. Plus the 10, take away the 4. Cannot take away the 4. What do? Minus the 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. That's my 6. And then I add my 3. So I'm going to add 3. Now we count. What? What are we doing? Because we're done with that. So now we need to reassess. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. When I do that, what do? 4 times 5. So now we start from the fifth column and descend. Yes, exactly. My finger is here. I want to do 4 times 5. Oh, hold please. Oh, okay. 4 times 5 is 20. Add my 2, add my 0, add 2. There's not enough to plus the 2. What do? Plus 2 is equal to plus the 10 minus 8. Plus the 10 minus the 8. Plus the 10 minus the 8. Plus the 10. Plus 1 equals to plus 5 minus 4. Plus the 5 minus the 4 minus the 8. And then 0. 2, 0. That's the 0. 4 times 3 is equal to 12. I add my 1. I add my 2. I don't have enough to add the 2. Plus 2 is equal to plus the 5 minus 3. So I'm going to plus the 5. I take away the 3. That was my 2. Okay, so now I have to do 4 times 7. 4 times 7 is 28. Add the 2, and I add the 8. I'm now done with 4. What is my next number? I have to count it. 1, 2, 3, 4. 1, 2, 3, 4. Uh-oh, I messed up somewhere. Because I was supposed to be here. 1, 2, 3, 4, 5, 6. I messed up something. Okay, so 1, 2, 3, 4, 5, 6. So we did 45, and then 21, and then 63, right? That's it. So 1, 2, 3, 4, 5. 4 times 4 times 1, 4 times 5 is 2. 2 plus the 5 minus, no, 2. Add the 2. No, what am I doing? 4 times 5 is 20. Add the 2, add the 0. Ah, see? Wait, is that right? Oh boy. Okay, let's see. Wait, hold on. 45 and then 27. Oh, maybe I get that wrong. And then plus 63 plus 6 plus the 10 minus the 4 minus the 4 plus the 3. So we're done with our 9. Now we got to do 1, 2, 3, 4, 5. 4 times 5 is 20. Add the 5, add minus the 20, 0. 4 times 3 is 12, plus 1 plus 2, plus 1 plus 2. 4 times 7 is 28. And then we're done. So now we can reassess. 4. 1, 2, 3, 4. I'm over here. Oh, see, that's what it is. 5 and a 0. Okay, so 2 times 10, 2 times 5 is 10. Add the 1, add the 0. 2 times 3 is 6. 6 is a single digit. I go back one column, I add 6. Add the 6 is plus the 10 minus the 4. Minus the 4 is minus the 5 plus the 1. And then 7 times 2 is 14 plus the 1 plus the 4. Woo! Okay. Nah, No, you know what it was is because the this B didn't come down. So, what is my final answer? 50675 4. That's what I got. So as a single digit, you go back. Yes, you go back one column because when you look at the single digit, pretend that there is a leading zero. So when I looked at it, I remembered I would do like if we talked about what? If we talked about time, right? 11:03. You know how there's a leading zero? So because there's a leading zero, I made this a two-digit number. So when we make our single digit a two-digit number, that's what we do is we would have a leading zero. It made sense to me when somebody showed me about a leading zero. I don't know if that makes sense to you. But the other way to know it is that if it's a single digit, you go back one column. And that's something that I've always excuse me, that's something I've always said. So you would treat it as a column when you start with yes, exactly. So every digit, yeah, you go back one column. I think it'd be best to think of it as two-digit numbers. Yes, I think if we stayed in the two-digit number realm, then yeah, I think so. I think that's a good way to think about it because you're always treating the column because you start from as the tens. I think so. I think so. I think it's a disservice if we start. I think it's a disservice to start from the ones. Um, but yeah, I mean, we do the same thing with division as well. We have to when we see a single digit, we always go back one column. Hey, fluffy gifts. Thank you for the follow. Whew, I'm at 14,000 Ks. Ha, Romario. Thank you so much. Yeah, I think it'd be best to call it that way. Yes, 0102. Like we do with our dates and stuff. Yes, I think it's best to do 1, 2, 3, 4. I believe that's a better way. Um, the translation is just better. But I mean, to each their own. Yeah. Some people get it, some people don't. Some people think it's a little bit too complicated. It's fine. Um, but yeah, yeah. I mean, obviously, there's no right or wrong. It's a lot about how does it work in your brain. And so I'm just trying to teach you the fundamentals. And if you think of it this way, then think of it that way. If you don't, that's fine too. Yeah, I think of it this way. I think of it this way, but because I'm teaching, I want to tell you what I'm trying to do. And so a lot of what I say is because I'm teaching as opposed to doing. Because usually, I don't say a lot of these things when I work in it. But again, because we're all beginners, it's better to have a conversation with the it's better to have a conversation, right, with the question. That's why we talk about it, right? And I feel like in mainstream math, we don't talk about our question enough that we don't understand our critical thinking. So that's why it's always like, do I have enough? Can I do it? Do I have enough? Can I do it? And I think that's where the critical thinking comes into play. Yeah. Okay, great. Ooh, is that the answer? I'm always so curious. How tired am I? Let's count the ways. 7 times that by 942. 50 no, see? 505 857. I was wrong. Why don't try to take We don't try to take it apart and ask why to make the mental connections. We don't try to take it apart and ask why. Yes, exactly. See, I'm wrong. 505. I did something wrong here. Now I want to go back and I want to figure it out. But it is what it is. And that's what it is. And so let because this is wrong, I would recommend do it again so you could see why you got wrong. If I 4 2, yeah, okay. Right? I think the main misinterpretation is the new math sees as whole numbers. Yeah, yeah, but I think with the new math, I think the problem with the new math is that they write it out and they're not using a math manipulative because there's nothing out there other than the abacus that does what they're trying to do. So with new math, it doesn't scale to the bigger numbers like this. So yeah, but now I gotta want to know. I know I messed up somewhere. So, but it is okay. I'll probably try it again later. Yeah, the misinterpretation is the new math sees the whole number. Yeah, I think so. It's I think the new math is also trying to get the kids to abstract think, but we don't do that. I get that urge so bad. Yeah. Okay, you know what? I'm gonna do it. I'm gonna do it. So I'm gonna do it again. 1, 2, 3, 4, 5, 6. So we have 45, 4, 5, right? This is 27. This is 60. 60. Is that right? Uh, 45, 27, 27, right? Now we do 63. 60, add the 10 minus the 4, and then plus the 3. 1, 2, 3, 4, 5. 4 times is 20 plus the 10 minus the 8, 0. 0. 4 times is 12 plus the 1 plus the 2. 4 times 7 is 28. 1, 2, 3, 4, 5. No, 1, 2, 3, 4. 1, 2, 3, 4. We're here. Ah, see, that's what it is. 5. And then 2 times 3 is 6. 6 is a single digit. I go back one column, I add the 6, plus the 1 minus the 4, minus the 4, and then 14 plus the 1 plus the 4. That's the number. 505, 505,864. That's what it is. Yeah, that's what it is. 505,854. So, teach mode to solve mode. Yeah, yeah. Abacus takes away the extra zeros. Exactly. You focus on the columns. And that's why I really like the abacus. And I'm not sure if there I'm not sure what the cons are. Cuz they talk about like does the kids really know what the quantity is? And I'm like I don't even think we know what quantity is either. Like I know what a dozen eggs look like, but do I know what 200 eggs look like? Does that make sense? Thank you guys for so much for the hearts. So that's the other question, right? Like, do we really know what 200 eggs look like? Quantity isn't shown with current methods. But see, that's the other thing. But no, I question I question, do we really need to know the quantity or do we just need to understand the numbers, right? So like the numbers are very abstract. Now we're going very philosophical, but like the numbers are very abstract, right? We don't know from a 5 to a 6 because they're just symbols, right? I know 5 fingers, right? And then 6. I know that. But then when I start, let's say there's 20 of us and we all have hands. I can't imagine how many hands that is. I know the number, but I can't imagine how many hands that is. You know what I mean? Because I think the human brain can only see like 5 things at a time. So I wonder what would be it I am not smart enough to see the quantity. I don't know if that makes sense. Right? Like I know what one lamp looks like. I know what two lamps look like. If you gave me like a whole set of lamps, I would have to count each individual one in order to know how many lamps there are. So knowing the quantity, I don't know. I don't know. I feel like knowing the quantity, it doesn't. It's cool to have a visual representation for each the step of the process to show the quantity. Yeah, yeah, yeah. I think so too. And it's concise. Like it's right here in front of you. But like this, if I did this 100, if I did like 151, this this is a visual representation, but that's all it is. It's a representation. It's not a one to one. The reason why I bring it up is because I know in new math, they start doing like this. They start doing the boxes. This box is worth 100. And then I have um uh rods. I have one, two, three, four, five rods, and then I have one dot. It's yeah. And then they start to figure out, okay, well, what if we add another 100, and then we add two more, and then we have nine dots. So then we have this, and I'm like, okay, and then we have to we one, two, three, four, five, six, seven, eight, nine. So then what happens is people are like, okay, well, this is going to equal to 10. So we got to convert it to a line. And then what happens? One, two, three, four, five, six, seven, eight. And then this is two. So then what happens? I think this one video demonstrates actual quantity really well. That's interesting. Let me know which one it is. But I don't know the benefits of understanding the actual quantity. I don't know. I don't know. I question this part. Like, I feel like it's animation versus, yeah, yeah. But like, if you tell me I have a million balls, I don't know. Like, that's a lot of balls. That's all I know. But other than that, that's all I know. You know what I mean? Like, what would knowing the numbers and how to utilize the numbers, I could see, but I don't know. Understanding the quantity, I'm not sure if it's needed. Like, I like how heavy is a ton? I don't know how heavy a ton is, right? So I don't know. I don't know. I do question like how far do we go with math and new math and stuff. But yeah, and I noticed that when and that's what I noticed. Like when I was talking about this with the new math, they actually go the same process at abacus, which is interesting. There's a limiting to understanding the quantity when it gets too big and too small. Yeah, see, that's what I'm saying. Like how far do we really want to push the kids to understand how big it is? That's what I wonder. Like, I really wonder what is the benefit of understanding like like a nanosecond? That's really fast. That's all I know. You know what I mean? New math is like hundreds and thousands. Abacus is one bead on the seven. Yes, exactly. Exactly. You're absolutely right. And with the new math, I think with new math, it just because you're writing it all out and then you have to line everything up, whereas on the abacus it's already lined up for you. So you can have a question, like some of the questions can be like super long and it'd be like, I don't know, um 27 plus 48 and then 33 and then 49, and then notice they're not lined up, but it doesn't matter on the abacus. Why? Because we take it for what it is. So every number, let me go back to this one, every number is, is called out. So we have 27, and then I go down and be 48 plus the 4 and then plus the 8, and then I have 30 plus the 30 plus the 3, and then I have 49 plus the 4 plus the 9 plus the 9 plus the 9, and then add the 1. So my final answer is 159. So it's interesting, like, do you have to like line it up in mainstream math, but in abacus you don't need to line it up, because when we do it, we go one at a time like this. This is how we do it. We don't do just the one column. So, and it shines, abacus more shines more when the numbers get bigger, but in mainstream math, I don't think you have more than just two add-ins, maybe three. In abacus we get like 10 add-ins. And that's part of the competition. Like, there's a world record. This guy, Aaron Schulk or something like that. He did 100 add-ins under 30 seconds. That's great. I don't know what the benefit is that. Do I push them? I don't push my kids to do that. I think there's a practical sense of understanding the abacus, but then I don't push it to like the extreme. Can they do it in their heads? Maybe, but I think knowing how to do it on the abacus just really helps all around. I don't think going to mental math helps because, like, look at our checklists, right? We always say, well, write everything down. Just write down your checklist. Okay. So then why are we trying to do so many math things in our head? So, with this part here, like, I don't know. I don't know. Now we're just philosophizing. All right. Um, do we want to do more math? Oh, I don't know the answer. Whatever. Yeah. But that's the thing. When we do addition and subtraction, when we do addition, we go through as one whole number. We don't do by columns. Okay. So if you guys are division, yeah, you want to do division, we can do division. Division's a little bit more, has more steps. But as long as I mean, you've been here for a while, so you kind of know that there's a little bit to it. It does get a little bit not complicated. It's just there's more steps. So the first one we're going to do, oh, and that's the other thing is we don't wait. You can't do negatives on the app. No, you can't. Because the question about negatives is how do you take away something, right? Like I could take away something from 9, right? 9 take away 4, that's a negative. But what's the question is how do you take 0? How do you take away a physical object from 0? That would be the question, right? And I think that would be a better explanation. Like I can't take away if I have 3 pens, I can't take away 4. What would it look like? Right? That's what I think when people ask me about that. You can do division, you can do fractions because fraction is just another form of division, and you can do decimals. But that's as much as it goes. I'm just thinking. Yeah, because I think calculus is more modern. Negative numbers is a more modern math. Because if you really think about the abacus was around when they were barter. After they bartered, they started using money, and so when they started using money, they started to do exchanges, right? So when does people back in the day? I'm assuming back in the day there was no such thing as owing, right? If you owed something, then you become a slave to somebody. Then you have to pay your way out. Maybe there could be new abacus that flips columns and shows the Yeah, yeah, you could invent that and then you would have to teach everybody how to do it. Because the problem is if this was ever a negative, let's say that we made this a negative, we made this a negative, but then we have addition as well. So then my question is how do you know? I don't know, maybe. I'd have to marinate on that one, but that could be. Okay. So let me look for a excuse me, division. Okay, let's do that. I need a bigger abacus. Yeah. Yeah, I was trying to figure out the whole division thing. The reason why was um the way I do it, I was trying to see what everybody else does, and you know what? It's interesting. A lot of the division questions are only single digits. So like this one. 52 divided by 4. So the first thing we're going to do, yes, start small. I will start small. Not so intimidating. So what's going to happen is, excuse me. Okay, we have to count our digits. Why? Because we need to know where we're going to put our answer. To put our answer, we know we have 2 digits in our divisor. We have our 2 digits in our dividend, and we have 1 digit in our divisor. So 2 take away 1 is equal to 1. So we know that our starting point is at 1. Just like when we do multiplication, but we added we added the digits, division, we subtract. So 2 minus 1 is equal to 1. We're going to start here. We're going to start here. This is where my answer is going to be. My answer is going to be here. So I'm going to put my dividend on my abacus. My dividend is this. And I made this little contraption that does like that. So what does that mean? That means I'm going to put my quotient here and I just take away from here. That's what I just did. So my first question is, wait. Oh, the reason why was because we need to know where we're going to put our answer. So we need to know that our answer is going to be at the 1 column. Now the question is we're going to compare. We have our dividend and our divisor. Our divisor is 4, our dividend, and we only compare the 1 digit. We don't compare 2 digits. We only compare 1. We compare the 5. Who is bigger? Our dividend is bigger. So then what do? We skip this column and we go here. We're going to skip one column, whoa, and we're going to go here. Why? Because that's one of the rules. So we only need to do is we need to understand 4 times what is equal to 5 or less. 4 times 1 is equal to 4. So I'm going to add the 1 here, and I'm going to take the 4 away. Take 4 away. So minus the 5 plus the 1. Now I'm left with 12. But what are we going to do? We got to compare. 1 is my dividend. 4 is my divisor. My divisor is now bigger. Because my divisor is bigger, 4 times what is equal to 1? No, because my divisor is bigger, I need the second number. So 4 times what is equal to 12 or less? Does that make sense? Yes, 3. So I'm going to put my 3 on the abacus. I put the 3 on the abacus and I take away 12. Take away 1, take away 2. So my final answer is 13. Hello, Helen. Hello. Does that make sense? Welcome to the real world. But that's what I'm saying. Like abacus is really makes everything really easy because you have a constraint and now you know where the box is. As opposed to I give you a blank paper and you try to figure it out. Division is a bit easier though. It can be. It can be. But these are steps you need to go through. These are steps and concepts that you need to understand. Well, how do you know if the division problem doesn't end? If it doesn't end, then you have a remainder. It just knows the rules. It's yeah. If it doesn't, if this, let's say we had, I don't know, 4, then we would have a remainder, and then you'd have to figure out when you want to stop, right? So it would be what 4 times 4 is equal to what? It'd be 3. So yeah, it'd still be 3, but then what it would be? It'd be 14 take away 12, take away 1, take away 2. Then what do? Well, then I have 20, right? And then I can do 5. So 0, so 13.5. Take away 2, take away 0. So, I mean, then you start going into decimals. But yeah, a lot of it is, yeah. If it keeps going, then then you would have to figure out when to stop. That's how I see it. Right, because some teachers want you to round up at a certain time or round down, or I think it's, preference to the teacher. but that's division. So, but I mean, yeah, and if you notice, and that's the thing, excuse me, what I notice is when we're teaching the children, when we're teaching division in school, we always say, okay, how many times can 54 go into 4? And I'm like, psh, I don't know. And then they start talking about, well, okay, well, let's start timesing it out. I'm like, what? So it's interesting. They're like, okay, if we know 8 times 4 is equal to 32, right? So then what happens? Well, how do I get to 48? I was like, well, if you're doing all of this, I don't know. I don't know. So then we have 16 times up by 4 is maybe the closest thing. I don't know. Maybe that's too much, right? Then we have to multiply it out. So I don't know. I don't know why we teach. I don't know why we teach it this way. Whereas it makes sense to me to be like, okay, this and this, let's do a comparison. So when we compare it, then we know what rule we're going to do. Why wouldn't they say how many times? Exactly. Exactly. Why are we doing the whole stupid number? Like, okay, here's another one. Let's do 2 digit. And this is what made me really mad. I got mad at this. I'm still here. I'm just looking for a question. That's not one. Let's do a different one. I never knew they're trying to do the whole number now. I don't know how they're doing division. I know there's one that they do like multiple subtraction, and I'm like, that's a lot of work. Oh, I'm still trying to find. I'm trying to find a 2 digit, and it was just interesting to see how we do it in abacus and how it's being done in school. Okay, here we go. Okay, here we go. So here is they use they use chat. You know, chat doesn't do abacus. I've checked. All right. So here's a question. And it's interesting when they do it. So the question is 43 divided by 2,494. And so it's interesting what they do is they say, okay, well, how many times does 43 go into this? And I'm like, what? That's kind of hard. So then you have to start multiplying it out. And I'm like, oh, that's too much. So here we do it on the abacus world. We actually do one at a time. We take away one, we try one. That's what we're going to do. So the first thing we're going to do is we're going to understand 1, 2, 3, 4, 1, 2. So what it is 4 take away 2 is equal to 2. Okay, I'm going to be here. I'm going to be here because I know what I know what I'm trying to do. So my 1, 2, my quotient will start here. So my quotient starts here. Start of the tens. Yes, exactly. We're going to start over here. So we have more room over here. And I like my colorful abacus. So we're going to start here. This is where my answer is going to be. I'm going to put my divisor, my dividend, right? My dividend is 2, 4, 9, 4. Now in mainstream math, they'll be like, okay, how many times does 43 go into 249? But in abacus, we do the same thing. We compare our divisor and our dividend. So we do divisor and our dividend. 4 and 2, who is bigger? Our divisor is bigger. So what does that mean? 4 times what is equal to 24 or less? Why? Because my divisor's bigger, I'm using 2 columns. 6, right? 6. 6, so I'm going to add my 6 here. I take away 20, I take away 4. Whatever I do to this number, I got to do it to this number. Oh no. All right. So now we do 6 times 3 is equal to 18. Now, if you look, 18, I do not have any more beads to take away 18. So now I need to do, now this, what does this mean? This means that my quotient is too large. I need to make it smaller. So instead of doing 6, I need to do 5. 4 times 5 is equal to 20. That's a rule. You take 1 from the answer, you make it 6, you make it 5, and then you come back here and you add the 4, right? You kind of step back a little bit. So now I do 3 times 5 is equal to 15. Take away 1, take away 5. Now what are we going to do? We got to compare. We have our 3 and we have our 4. Who is bigger? 4 is still bigger. So what am I going to do? I'm going to 4 times something is equal to 3, but I need the next number, which is here, 34. So anything 20 and above is too big. No, it's what you were trying to do. So let's go back. 2, 4, 9, 4. So when we add the 6, we take away 20, we take away 4. Okay? So now what we're going to do, this is when the quotient is too big. What we did was we're trying to figure out where the quotient sits. But we know it's too big. What do? So 6 is too big. We got to make it to 5. Does that make sense? It's not anything higher than 20. It's not that. So because this is 5, because 6 is too much, I got to make it to 5. So I'm going to change this to 5. So what is it? 4 times 5 is equal to 20. Notice I add the 4 here. Why is 6 too big again? Oh, because 3 times 6 is 18. I'm trying to take away 18 from here. 1 and 8. I don't have enough beads to minus the 1. So now you need 3 beads for the third section. Not 3, 4. This is where it gets a little complicated because whatever you do to this one, you got to do it to that one. So what this is distributive property inside a division, inside division. So it's not adding 3, we need to add 4. So now we do 5 times 3 is 15, right? So take away 1, take away 5. Did that make sense? So when the quotient is too large, we got to bring it down a notch. But because we bring it down, because we bring the quotient down a notch, that means we got to raise our dividend. So instead of subtracting 24, we're going to subtract 20. Does that make sense? I laugh because this is what I'm struggling with. This is one of there's a lot of these things when the quotient is too big. When the quotient is too big, you need to go down a notch. So you have to add the divisor, and then you have to take out. So instead of doing 6, you do 5. Okay, so 24 is too big. Yeah, so yes, that's what it is. Taking away 24 is too much. You literally cannot subtract. No, no, it's not that one. It's the other one. It's 6 times 3 because 6 times 3 is 18. I'm trying to make sense of it in my mind. Yeah, it's a little bit. But don't forget, Rome, you just started with abacus. So if you don't understand it this time, you'll get it the next time. It just takes a little bit of time to marinate. So if you look at it, right? So when we look at it, we did 24 and that's too much. Cuz now we don't cuz now we're what we need to do is whatever we do to this number to the 4, we got to do it to the 3. So what happens is if I did 4 times 6, then I have to do 3 times 6. You're doing great teaching. Oh, thank you. I appreciate that. But don't forget, you just started. So there's a lot of things that's happening. One thing is to understand a lot of the things. So what I want to do is I want to take away 18. I cannot take away 18. Yeah, it's not the 24, it's the 8 times, it's the 6 times 3. I cannot take away the 8. I cannot take away 1 and 8. So I have to, so 20, so taking away 6. Yeah, so taking away the 6 is too much. I got to remove the 6. Now I'm making it a 5. So if I make this a 5, I need to put back the 4. So I'm going to put back the 4. Okay, good. Okay, good. So then now I could do 5 times 3. When I do 5 times 3, it's 15. Can I take away 15 now? Yes. Yes, I can. So I'm going to take away the 1 and I take away the 5. Minus the 5 is minus the 10 plus the 5. Okay. Now I'm going to, we are still descending. Yes, we will still descend. It's just like subtracting. So my dividend on my abacus is a placeholder to know where to put my quotient. So that's why I had this thing to show where my quotient is. So as I finish the dividend, I just move it down a little bit. So now my quotient is going to be over here. My dividend starts here. So 2 or 4. 4 is bigger. So what do? I have what? 4 times what is equal to 2? No, I need to utilize this next number, which is 9. So it's what times 4 is equal to 29 or less? 4 times 8, right? 4 times 8, 7. 4 times 7 is equal to 28. Yes. So I add my 7 here. I add 7. Is that even right? That's not right. That's not right. I did it wrong. 24, 9, 4. So I add 6, 24. That's too much. I add and I take away. So take away 1, take away 5. That's what it is. That's what it is. So we're here. We're here. 34. 34. Yeah, because that's what I did here. 34. So 8, right? 4 times what is equal to 34? 34 or less. 4 times 8. So I add my 8, take away 30, and then take away 2. So I'm going to take away 2. 8, whatever I do to my 4, I have to do it to my 3. 8 times 3 is 24. Take away 20, take away 4. Take away 2, take away 4. Did that make sense? Wait, why did you only add 2? Oh, because I made a mistake. So if we look, we did 2, 4, 9, 4. So we did 6, right? We did 20. I'm sorry, we did 24. So we did take away 20, take away 4. 6 times 3 is 18. Cannot take away 18. So I take 1 away and I go back and I add the dividend. I add the divisor because I did too much. So now I have 4, 9, 4. 4, 9, 4. So what do we do? 3 times 5 is 15. Take away 1, take away 5. So then we're left with 3, 4, 4. And then what do? I compare 3 or 4. 4 is bigger, so what do? 4 times what is equal to 34 or less? 4 times 8. 8 is my quotient. Take away 30, take away 2, because 8 times 2, 8 times 4 is 32. That's why I take away 2. 32. So I'm left with 2 and a 4. Whatever I do here, I got to do it to the other divisor. These two are the same, right? I got to do it here. I got you. I was thinking about the wrong number. Yeah, I made a mistake. That's what it was. And so 3 times 8 is equal to 24. So my final answer is 58. Yeah. Hey, Ethan, welcome back. We were just doing some division. Yeah. Yeah, and it gets a little, yeah. Yeah, that's correct. But see, that's the thing. So instead of saying how many times can 43 go into 249, looking at this, it makes it a little bit more manageable chunks, right? So division with big numbers is tough. Yeah. Yeah. And I know there's a bunch of other ways to do it, like do multiple subtraction, but I think doing it this way, I mean, obviously it's all about practice, but you still got to do critical thinking here. Do you can you do where the answer is a decimal? Yeah. Let me excuse me. Are we doing adding and subtracting, Ethan? Or are you talking about like division? Division. Is there a specific question? Do you have a specific question? Because I'm kind of tired right now. So the ultimate rule for division is the last number has to take the rest of the beads. The ultimate rule is whatever you do to the first divisor, you got to do it to the second divisor. 18 divided by 3 is just 6. No, because it can be repeating decimals. Correct. It can be repeating decimals. Yes. Exactly. You could have a remainder. But I think the ultimate rule is whatever you do to the first divisor, you got to do to the second one. They have to be done as a pair. They cannot go out of sequence. They cannot go out of sync. So the question is 20 divided by 9. So if I did 20 divided by 9, 1 would be my, and then I would lock it up here. So 9 times what is equal to, so it'd be 2, take away 18, take away 1, take away 2, take away 2, take away 1, take away 8. Why is it 10 plus the 2? It would just look like that. That's what it would look like. So I would have to do it again. So 2, right? 2 times 9. So I add my 2 here, and then I'd just be doing that. So it would just be doing repeating. And that's what it would look like. And then it would go on forever. The 4 couldn't be multiplied by 6 because there isn't anything left. Yes, exactly. Exactly. So yes, Ethan, the answer would be 2.22222. And it'd keep going until you can stop it. But yes, yes, Rome. Yes, it's exactly what it is. 4 cannot multiply by 6 because there's nothing left for the 3. That's exactly what it is. The 4 can't take everything. The 3 needs to do something. Yes, that's exactly what it is. Yeah. Yeah. And it's interesting like how they do it. But see, the funny thing is when you compare when you compare just regular mainstream math to division, I don't know. I don't know why you're alive. You still live. I feel like it's super late for you. Oh yeah. You're right. It's 12:41. It is late. Um, and I actually just got a little bit tired. I came on a little bit late. But see that's what I'm saying. If you did research on div, two two digit division, everybody's going to be like, "Well, how do you get 43 divided by 249?" And I'm like, "What the heck?" It's almost, oh my God, Romero, it's 3 a.m. And you're doing math voluntarily. That's crazy. You're nuts. Yeah. And I was doing research, like how does the mainstream math do division? And it's interesting. They take the whole number. So even if we did like, I don't know, even if we did like, I don't know, I feel like this way is more scalable. So we can do another one. But yeah, I hope we can get division dedicated live because my brain refuses to comprehend fully. you know, okay, I understand. It is a little tougher when there's new people coming on. new division, new division math, new division math is multiplication. Are you talking about in mainstream math or are you talking about abacus math? Because abacus math is multiplication. Just what's the add in? Yeah. Oh, mainstream math, really? Yeah. I don't remember how to do mainstream division. It's been so long. Because you can get decimal divisors and then decimal dividends and it adds to a whole number is a whole nother hurdle. No, I was looking at that too, and how do we do it in abacus? And I think in abacus we would just do the same way. If we had our divisor, right? Like 0.25 divided by, I don't know, 478, you would still need to move the decimals. You could still do that. You could still do that, right? I think that still makes it a lot cleaner. How do we do that in the abacus? It'd still be the same. It would still be the same because we would count, this is 0 and this is 3. 1, 2, 3. What did I do? Oh, I did this. I did 0 minus, nope, 3. 3. I don't know. This would be 3 somehow. So, no, this wouldn't be 3. Would it be 3? I had it and then I forgot it. But you would still move the decimals. You could do that. So then we'll be left with 225, 37500. So adjust the problem beforehand. I think so. I think it's just cleaner if you adjust the problem. I think with the decimals, I think it's just easier if you adjust the problem. I mean, cause why? If I think about the history of if I think about the history of abacus, when did we ever do decimals? The only time we did decimals was when we had money, right? When we had change. So I think doing decimals, I think is still like a new it's a modern concept. So that's why I think we still need to divide out our decimals. So we could do, if you want, we could do, excuse me, we'll do this one. 39. Oh, I should use a different color. 39. Machi, I agree with you what you said. Division is kind of its own line. 39 divided by 975. All right, that's a 9. This is a 9. So what are we doing? Well, 1, 2, 3, right? 3 take away 2. So it'd be 1. 1. 1. We'll do 1 here. Why? Because I don't have enough space over here. So now if I put this here, there's my quotient, 1. So I put 9, 7, 5. My brain right now. Yeah! Yeah! Okay, we'll take this one and then we'll head out. You gotta go to bed! I can't believe you're up so late. So the first thing we're gonna do is we're going to understand which is our divisor and our dividend. Our divisor and our dividend. So what are we going to do? We're going to compare this one and that one. Our divisor is 3, our dividend is 9. Because the dividend is smaller, we're going to only use one column and only one, and we're going to skip one column. So 3 times what is equal to 9 or less? 3 times 3 is equal to 9. So I add my 3 and I take away the 9. Okay, now there's a problem. Why? Because 3 3 times 9 is 27. Yes. So now we know it's too big. So we should do take away the 1, right? We got to go back and then we got to add the 3. So now 2 times 9 is 18. Take away 1, take away 8. Take away 8 is minus the 10 plus the 2. Yes, exactly. 3 takes away everything. So then we got to go back and yes, exactly. So when we do that, we need to compare again. 1 and 3. Who is bigger? 3 is bigger. So now when I look at it, it's 3 times what is equal to 1? No, 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 no. Because 3 is bigger, I need to have one more column. So this is the one more column. This is the 9. 3 times what is equal to 19 or less? 3 times 6 is equal to 1 equals to 8. Is that right? Did I do that wrong? I did do that wrong because I need 75. Wait a minute. I did that wrong. But you're right. 9 takes too much. Okay, wait. Sorry. 975, right? And then we take away 2 times is equal to 6. So then 2 times 9 is equal to 18. Take away 1, take away 8. Take away 8 is minus the 10 plus the 2. Okay, so then 19. So take away 1. So add the 6, take away 1, take away 8. 5, 6, 7, 8. 6 times 9? That's not right. What am I doing wrong? I feel like what? Did I copy that wrong? 39. Okay. So what are we going to do? We're going to do too much, right? Because 6 times 9 is 54. Yeah. 6 times 9 is 3. 6 times 9. What? No. No, we're good. We're good. Because now this is too much. So we got to take 1 from here, and then we got to add the divisor because it's too much. Oh, okay. Let me do that again. 3. Sorry, 3. Now I know I'm tired. 9, 7, 5. Right? 3, not enough. So I go back. Take away 6 is 3. Right, right, right. You're right. 2 times 9 is 18. No, I got that. Take away 1, take away 8. Take away 8 is minus the 10 plus the 2. No, we're good. So then 6 times 9 is 18. Take away 1, take away 8. Cannot take away the 8, right? 6 times 9 is 54. 54 is too much. So that means we have to take 1 from the answer, add the divisor back. We can do 5 times 9 is 45. So our answer is 28. 25. Yeah, yeah. So that we take away 4, take away 5. Whew. But at least Machi knows. 18. It's collecting, yeah, it connects a little bit more because we do a little bit more and you start to see the numbers. Oh, whoa, there's still 9 people in this room, but 2 people are talking. So I was missing one part. Yeah. It's the going back saying that there's too much. So you take 1 from the answer and you go back and you have to add the divisor back. And I thought that was a very interesting concept. Whoever like whoever broke down abacus, it was really interesting like how their brain worked. Like it's crazy like you could do it this way. I mean, the first person that thought of it this way, I was like, "What?" That's where I missed it. Yeah. Yeah, this one happens to be you'd had to do it twice. So we did it the first time when we did the 2, and then we had to do it again when we did the 5. I wasn't counting on what was left of the divider or subtracting with the second answer. Yeah, yeah. It's a different way. But I think I like it this way even still because we break up the divisors by itself. And it's just easier to manage than to say, okay, how many times can 39 go into 97? uh, that's a lot of multiplication. Right. Okay. So it is very late for everybody. I appreciate you guys joining in and commenting. And I'm happy that I'm getting a better handle at explaining the when the quotient gets bigger. But I'm telling you, like it's one thing to talk about it, but it's another thing to try to learn it and try to explain it to like completely explain it because it does take a little bit. Yeah, I'm actually on a trip in Indonesia, so it's daylight. I don't know why. It is. Thank you so much for explaining the abacus. It's amazing to see the tool to be used. Yeah, not a problem. I appreciate your comment and you're able to like understand it and stuff. Machi, why are you learning math on your vacation? It's so funny. Oh, check to see. You know what? Check to see if Indonesia has some abacus for you. See if they sell abacus. They might have abacus for cheap. They call me Matthew Mallow. I wonder if they have that. Yeah, check to see if you wanted an abacus, check it out in Indonesia. They might be really cheap there. I love math. I've always been interested in the abacus. Oh, really? That's really interesting. And it's too bad that it's not more well known. But I believe it's quite popular in the eastern countries like India is it's huge in India. Japan because they have the Japanese. There's competitions, and I think Chinese don't do it as much anymore. But yeah, yeah. But it is interesting to see how they can do multiplication and division on the abacus and make it manageable chunks. And I find that that's been pretty interesting. So, all right. But I can talk, but I can't talk. I need to go to bed. And you need to go to bed too, Romero. My God. Romy, Romero, Romeo Rome. Romeo Rome? Machi, Matthew. I don't know if Ethan's still around. Oh, hello, Kevin. I know the history, the whole barter stuff. Yeah, Genghis Khan changed that. Oh, that's interesting. That's interesting. Yeah, I know the abacus came from Mesopotamia, but it started off with pebbles. And an abacus actually just means moving pebbles. And it was like right around like the Greeks and stuff. Romy Rome. Oh, okay. Romy Rome. Okay. Cool. Thank you. Um yeah, it's interesting like the whole history behind it. And then, there's the Chinese one, and then the Japanese made it more efficient. And now I'm trying to popularize it. I'm trying to make everybody in the world know what an abacus is. So, but yeah, I appreciate everybody joining. It is very late. Thank you. Thank you. I hope it works well. I hope it does, I hope it works well. Like I really do want it to go into the mainstream math because I feel like it really would help the kids. But then I wonder how much kickback I get. You know what I mean? Like they don't. I don't know. Anyways, but thank you. No, thank you, Machi. Thank you so much for joining and talking and like understanding. I do appreciate it. Yes. Have a wonderful evening. Yeah, go. Have a good nap, Ro. Have a good nap, Ro. Teachers are getting so much kickback regardless. It's crazy. Yeah, that's the one thing. That's the one thing. And it's too bad. But, oh, sorry. All right. So have a good night, and I'll see you guys in my next live. Bye. end.